Welcome to this explainer. Okay, let's jump straight into a real-world scenario. Imagine you're walking into the office, grab your coffee, and sit down at your desk for day one. You've just been hired as the brand new senior data engineer for a company called AdventureWorks. It's a big role, the tasks are critical, and today we're going to walk through exactly how you execute your first major assignment.
Your mission, right out of the gate, is to automate their day-to-day database operations. See, AdventureWorks relies heavily on their databases running at absolute peak performance. They can't afford slowdowns, so they need you to configure a crucial digital tripwire for the system. Basically, you're building an automated alarm system that keeps a watchful eye on the database 24/7, so human eyes don't have to.
Here is our roadmap for the operation. 1. Your data engineer mission. 2. Setting up the environment. 3. Deploying Azure SQL Server. 4. Configuring the CPU alert. And 5. Cleaning up resources.
Let's dive right into Phase 1, your data engineer mission.
If we look at the official source documentation for this operation, it outlines an estimated 20-minute time frame to secure the infrastructure and get these automated methods deployed. That's literally less time than it takes to eat lunch. In 20 minutes, you're going to fundamentally improve the reliability of the entire AdventureWorks database. Pretty cool, right?
Moving right along to Phase 2, setting up the environment.
To get started, you definitely don't need to write everything from scratch. You'll just execute these 3 rapid-fire steps. First, crack open Visual Studio Code. Second, bring up the command palette and run a git clone. You're going to pull down the required database administrator files directly from the Microsoft Learning GitHub repository. And finally, just save that repo right to your local C drive in a folder called Lab Files. Boom, your environment is prepped and ready for action.
Which brings us to Phase 3, deploying Azure SQL Server. Inside VS Code, you'll open up an integrated terminal. This is essentially your command center. We're skipping the endless menu clicking in the portal and using the CLI instead. You just type AZI login to authenticate, and then run the deploy SQL database script. And honestly, this script is about to do all the heavy lifting for you.
What's really cool is how much this script handles in the background. By default, it spins up your database in a resource group called Contoso RG out in the West US2 region. But even better, it bakes security in right out of the box. It generates this random 12-character complex password for the SQL admin. Uppercase, lowercase, numbers, special characters, the whole shebang. It actually even detects your current public IP and auto-adds it to the firewall rules so you don't accidentally lock yourself out of your own creation.
Now listen up, because this is absolutely crucial. When that script finishes, it's going to spit out several specific output values right there in your terminal. You need to grab the resource group name, the SQL server name, the database name, and that complex admin username and password. Copy them to a notepad, save them somewhere safe, because you literally cannot complete the rest of the mission without them.
All right, on to the main event. Phase 4, configuring the CPU alert.
We're pivoting from the command line over to the Azure portal in our browser. The documentation gives us the exact coordinates to navigate the portal and protect our brand new database, which is named AdventureWorks LT. We are setting up a guard to watch its CPU usage like a hawk.
Now, the Azure portal can be a bit of a maze, right? But we're cutting straight through the noise. Just hit the search bar, type SQL databases, and click on AdventureWorks LT. On that main blade, scroll down to Monitoring and click Alerts. From there, it's a super simple click on Create Alert Rule, and we'll select CPU percentage as the exact signal we want to track.
Here's where we define the rules of engagement. We're setting up what Azure calls a static threshold. We set the aggregation type to average and the value property to greater than. You might be wondering why average. Well, CPU spikes happen for a split second all the time. That's normal. By monitoring the average load over a set period, we filter out the noise and prevent those annoying false alarms. We only want to be bothered if the CPU is genuinely struggling for a sustained amount of time.
80%. We punch this value right into the threshold box. This guarantees we get officially notified the absolute moment the CPU exceeds an 80% average. It's really the perfect sweet spot. It's high enough to signal a legitimate problem, but it leaves enough headroom, that remaining 20%, for you to actually log in and fix the issue before the whole database goes offline.
But hey, an alarm is completely useless if nobody hears it going off, right? That's where action groups come into play. To make sure the alert actually reaches you, you'll set up an action group named Email Group. You set the notification type to email, check the box to use your specific Azure sign-in credentials, and name the notification Demo Lab. Now the system knows exactly who to ping when that 80% threshold is crossed.
To wrap it up, you just tab over to Details,
Give your new alert rule a recognizable name and hit Review plus Create. Once you hit Create, boom, your automated digital tripwire is officially armed and standing guard. If that CPU usage ever creeps over an 80% average, an email will instantly drop into your inbox.
Finally, Phase 5, cleaning up resources.
A smart engineer always cleans up their mess. Plus, leaving unneeded lab resources running is a fantastic way to rack up a massive, unexpected cloud bill. The source text actually presents a crossroads here, giving us two distinct methods to safely tear down the environment. It all depends on how you initially set up your workspace, and you want to be careful here so you don't accidentally nuke someone else's work.
You've got to weigh these two options. Option 1, if you spun up a brand new resource group just for this exercise, you can delete the entire thing. It wipes the slate completely clean, destroying everything inside it in one shot. Option 2, if you used a pre-existing resource group that houses other important projects, you have to do a surgical strike. You only select and delete the specific resources that start with your SQL Server name.
Whichever path you take, Azure actually has our backs with some built-in safety rails. You navigate to resource groups, select your target, and click Delete. But it won't just let an accidental click ruin your day. You literally have to explicitly type out the confirmation text, like the resource group name or the word delete, to authorize the destruction. After that, just sit back and let the portal clear it out.
I love this final note from the manual because it hints at the real power of what we just built. We just sent a simple email alert based on CPU. But as the text points out, you can trigger webhooks. Imagine an alert that actually triggers a webhook to scale up your database resources on the fly, instantly fixing a performance bottleneck while you're fast asleep. That is next-level automation.
So, Senior Data Engineer, you've successfully deployed an Azure SQL database from the command line, and you've protected its compute power with an automated alert. But with this highly customizable system now in your toolkit, what other metrics are you going to automate next? Are we looking at database size? Deadlocks? The possibilities here are literally endless. Thanks for hanging out with me for this explainer, and I'll catch you on the next one.
Everyone. In this section of DP-300 Database Administrator Labs, we'll go through the lab number 12, which is create a CPU status alert for a SQL server. So think that you have joined in a new workplace and you would like to monitor the performance, setting up some kind of alert. So in this lab, we'll go through setting up a alert and see that one through like kind of monitoring system. So I'll share this GitHub link so that you can follow when you do into your lab setup or own environment. Make sure that you have downloaded all the required files beforehand. So here I have connected to my server. Now let's go to the downloaded script that I have done. So now open that in a terminal window, like terminal window. Let me zoom in. Now log in to connect to Azure portal. So this will prompt you browser window for logging in. Log in using your user ID and password. So this is mainly him. Okay, it gets my subscription ID and tenant. So press enter to consider or take that values. Now we're going to set up a SQL server and a SQL database. And for that, when you go through, you need a resource group. In your own lab environment, you can set that up and use uh, to set up metric. And if you lab environment, you can just execute the a script, PowerShell script. So the command is here. We are going to change directory to setup, and there is a PowerShell script. If you go there, labs, and then if you go to that setup, you can see that there's a PowerShell script. Then you can go through that one and press enter. So it is using the values that has been defined into that PowerShell script based on that. And if you want, you can change those values. Like you can see that there are parameters like resource group name, location. Let me go there, and if you open that, so here you can see that the resource group name. Then you can see the location, then password. So you can modify this one based on your requirements. So when that completed, you can see the deployment results here. It's giving a resource group name, is giving a SQL server name, and also see the password informations. And now let's connect to the portal. And you can go to resource group, um, and under resource group, you can see the resources. So here you can see that SQL server and SQL database informations here. So select that like SQL database and AdventureWorks LT. And you on overview section, you can get like different summary wise informations. And you can see that there is a monitoring sections also, like it's a basic monitoring already in place that you can monitor that one. Now, if you go to that here also, you can see that monitoring. If you expand that, then you can see there is a alert option. Select that alert because you are going to set up some kind of alert so that we can get notification. Now you can going to create an alert rule. Now, if you see here, signal name, you can see that there are different types of signals here available. And you want to get more, you can select that see all signals. So is that based on metrics, you can see those different categories available here. Let me close this one. So now select that one. We are going to do that CPU percentage. And then next select that. When you did that one, it get that alert log section. So here first threshold type, we said that is static. Then aggregation type here is average, and the value is greater than, and threshold is 80. And when to evaluate, we can see it is mentioned that every 1 minute, and loop back period is 5 minutes. So we are just taking all the default values for now. So next, select on actions, and there are options like you can create an action group, or if you created action group before, you can add that on here. So here select that create action group and select the subscription, select resource group, select region, give a action group name. And also display name. Let me set that one same. But you can see that it is mentioned that limited to 12 characters. Then select next notification. And notification here, you can see that notification tab. There is a two options is email Azure Resource Manager role or email. So in this case, we are selecting email, SMS message, push, or voice. Then this type, when you select that one, it's giving an email to put it here. So let me set this email address here. And you can see that you can set up SMS, you can set up as your mobile app notification also as a voice. And down below that enable the common alert schema. So we are not changing that one. No, only thing we just set that up email notification, setting that email. And there is a name that we need to add for this one. So let me give a name. Then here you can see that a review and create options. We are not just changing anything here. We are just taking the default options. So select review plus create. When that's done, select create options. So now you can see that email group has been created and this has been set up. So when this alert in place, what will happen if that exceed the 80% and email is sent out? So that's the thing, like this lab is mainly to set up alert for CPU related informations. So if you have any questions, please add that into comment sections. Otherwise, I will see you into next lab.